Hi there, I'm Kunal and I scored a 760 on the SAT Math section and a perfect score on the PSAT Math section. I'm going to help you guys get to that point starting with today's lesson on linear inequalities. First, I'm going to go over the symbols you need to be familiar with for this lesson. The first one is the equal sign, which you all probably know by now. But in case you haven't seen the rest, they are symbols that are associated with inequalities or non-equal relationships. They are less than, greater than, less than or equal to, and greater than or equal to. With that in mind, here are a couple of examples of equations versus inequalities. As you can see on the left, an equation is any relationship that has an equal sign. But on the right-hand side, we have non-equal relationships between variables and constants. So we have y is greater than 3x plus 5. We have 2x plus 4 is greater than or equal to x minus 3. And we have y is less than 9. These are the three inequalities I just mentioned, but they're represented graphically. So the shaded regions represent the values that satisfy the inequality. So you might notice that I have some dashed lines and I have some solid lines. The dashed lines are used to represent less than or greater than relationships. These mean that the values can be very close to those numbers, but will never actually reach them. To indicate that, their graphs are dashed. The solid lines, however, indicate that the points on the line are included in the region, and they are for less than or equal to or greater than or equal to relationships. To solve inequalities, you apply the same steps as solving equations with one exception. Whenever you multiply or you divide by a negative number, you're going to have to flip the inequality sign. So let's first solve an example where we do not have to do this. So we have 2x plus 4 is greater than or equal to x minus 3. And solving it using our algebra skills, we can figure out that x is greater than or equal to negative 7. Graphically, we can see that there's a solid line at x equals negative 7, and then everything in front of that is shaded. Now we have negative 4x is less than x plus 25. First, we combine like terms to get negative 5x is less than 25. Then we divide by negative 5 on both sides and flip the inequality to achieve x is greater than negative 5. Graphically, we can see a dashed line at x equals negative 5, and everything above that is shaded. So since the line is dashed, x cannot be negative 5. Now let's get into compound inequalities. This is a relationship that forms a range of values the variable can be. We can see in this case 5 is less than 2x minus 3, which is less than or equal to 9. So when performing operations to isolate x, make sure you do them on all sides of the inequality. And as before, if you multiply or divide by a negative number, you have to flip both signs. So first we add 3 on all sides, and then we divide by 2 on all sides to get 4 is less than x, which is less than or equal to 6. To graph this, we know that x is greater than 4, since we know that 4 is less than x. So we have a dashed line at x equals 4, and everything above that is shaded. We also know that x is less than or equal to 6, so let's make a graph for that. Then, for the compound inequality, we take the shaded region that's between these two inequalities, where we have 4 is less than x, which is less than or equal to 6. Thank you so much for watching today's video. I hope you learned something new and are now ready to kill it on the SAT Math section. For more practice problems and access to a 24/7 online study tool, check out ACEIT at the link below. ACEIT is the ultimate study tool for the SATs and the ACTs created by Juni Learning, an award-winning educational tech platform that has helped thousands of students take their learning to the next level. Get a 1-week free trial when you use the link in the description. Until next time, and good luck studying!